Many people think green energy is all about solar panels and windmills, but the harsh reality is this. Our modern civilization relies heavily on a silvery metal buried beneath Kazakhstan's soil, uranium. However, digging up this metal is only the beginning of a very dangerous geopolitical game. Imagine having the world's largest energy reserves, but you can't use them without the technological help of the West's greatest rival. Why does a superpower like America still have to look to the East just to keep the lights on? It all comes down to a secret process called enrichment. Without this process, uranium is just useless ballast. We're talking about the most closely guarded supply chain on Earth, where a single technical error could mean total darkness or a radiation apocalypse. The nuclear world has a hierarchy, and at the top stands Kazakhstan, a giant that accounts for over 40% of the global uranium supply. But here's the irony. While Kazakhstan holds the key, it doesn't own the door. It ships its raw uranium to Russia for processing. Why? Because natural uranium is a very stingy alloy. Within the ore, there are two isotope siblings, the stable but passive uranium, 238, and the extremely rare but fissile uranium, 235. The problem is, U-235 only makes up 0.7% of the total mass. To run a power reactor, we need a concentration of at least 3% to 5%. The process of increasing this concentration is called enrichment. The first step is to convert uranium rock into a thick yellow powder called yellow cake. But this powder cannot be enriched yet. It must be converted into a corrosive gas, uranium hexafluoride, UF6. This is where Russia takes control through its massive enrichment facilities. By exploiting the very slight difference in atomic weight, U-235 is slightly lighter than U-238. This gas is spun in thousands of centrifuges at supersonic speeds. This centrifugal force slowly sifts these precious atoms from the other isotopes. Once the uranium gas has been enriched, it can't be directly thrown into the engine. The gas is recrystallized into a black powder and pressed into hard granules called nuclear fuel pellets. Don't be fooled by their fingertip-sized size. A single granule contains the energy equivalent of 3 barrels of oil, or nearly a ton of coal. These grains are then neatly arranged inside long pipes made of zirconium alloy. This material was chosen for a reason. Zirconium is resistant to extreme heat and does not impede the flow of neutrons, the bullets in nuclear reactions. This collection of pipes is called the fuel assembly, the heart of a nuclear reactor. Inside the reactor core, these rods are immersed in extremely pure water. The water here acts not just as a coolant, but as a moderator. Without water, neutrons would fly too fast and fail to split the uranium atoms. Water slows them down, creating a stable and controlled chain reaction. As the atoms split, they release tremendous heat that boils the water, creating steam that turns the turbines of the electricity generators. This is the pinnacle of human engineering, taming the destructive power of atoms into a steady stream of electricity. Managing enriched uranium means playing with unforgiving risks. History has recorded disasters like Chernobyl and Fukushima as memorials. The primary problem is almost always the same: cooling system failure. If water supply stops, the residual heat from atomic decay can melt entire concrete and steel structures, releasing radioactive clouds into the atmosphere. That's why the modern nuclear industry is now shifting to Generation 4 reactor design. These reactors are designed to be fail-safe, meaning that in the event of a total power outage, the reactor will shut down automatically without the need for human intervention or electric pumps. However, behind this technological sophistication lies another major challenge: nuclear waste. Spent fuel rods remain radioactive for thousands of years and require underground storage facilities capable of surviving beyond human civilization itself. The world is currently at a crossroads. On the one hand, we need massive amounts of clean energy to halt global warming. On the other, dependence on supply chains from specific countries creates geopolitical vulnerabilities. Kazakhstan and Russia may hold the upper hand today, but the race to develop small modular reactors, SMRs, and waste recycling technologies is underway. Enriched uranium is key to a zero-carbon future, but only if we can manage it with absolute transparency and security. Uranium is more than just a metal. It is the currency of power in the 21st century. From the mines in the steppes of Kazakhstan to the centrifuges of Russia, every gram of enriched uranium carries the potential to light up the world or destroy it. We are entering an era where energy independence will be determined by who can most safely tame the atom. Is nuclear power a savior for the planet or a ticking time bomb? The answer lies in the technologies we develop today.